Welcome back, ladies and gentlemen. We are still in Chapter 5. We are in Section 5.2, and this is our second day of 5.2. Today we will be looking at two-way tables, probability, and the general addition rule, as well as Venn diagrams and probability. Now, by the end of this lesson, you'll be able to use a two-way table or Venn diagram to model a random process and calculate probabilities involving two events, and you'll be able to apply the general addition rule to calculate probabilities. At the end of this lesson, try these problems. Let's get started. Now, once again, you should look at our course materials for this in-class example. It should have already been completed. And let's go ahead and dive into the meat of the lesson. So you can read much of this information on pages 346 to 349. And when asked a question involving the word or, two different scenarios can emerge. In one scenario, the word or is truly intended to ask you to choose one item or the other, and you can't have both. Those would be our mutually exclusive situations. Now, in the second scenario, the word or gives you more choices because you can choose the first item, the second item, or both. When this second scenario occurs, we are no longer dealing with mutually exclusive events, so we need to adjust our general addition rule. All right, now, this is an example of two different scenarios where you could have both events occur. If someone asks you, would you like a small, medium, or large coffee? You could answer any one of those three. Would you like cream or sugar for your coffee? You could answer either one of those, or you could have both. All right, now, in this scenario, small, medium, large, you could only really choose one of those. Cream or sugar, you could have one, the other, or both. And if you combine these two questions, then you could have small, medium, large, cream, sugar, both. Right, so if you're only asked the first question, you can only answer one of those. If you're asked the second question, there is that option for both. Now, when you're trying to find probabilities involving two events like A or B, a two-way table can display the sample space in a way that makes the probability calculations easier. Two-way tables are really preferable when you're just dealing with two events because it shows us everything. It shows us the marginal probabilities, the conditional probabilities. It shows us basically everything. A Venn diagram is a little bit less useful when you're dealing with two events. Now, once you get to things like three events, you kind of have to. All right, so let's take a look at the next page. All right, so what is a two-way table? Now, our definition, a two-way table is a table of counts that summarizes data. This was a typo. Instead of that, please write down data. That summarizes data on the relationship between two categorical variables for some group of individuals. So you're dealing with two different variables. Now, I want you guys to remember, we worked with two-way tables back in section 1.1. Right, if you need to, review those notes. Each of the two sides of the two-way table refer to a different categorical variable. Right, it's a different variable. Think of it as questions that were asked. Right? So for example 1, students in a college statistics class wanted to find out how common it is for young adults to have their ears pierced. They recorded data on two variables, gender and whether the student had a pierced ear, for all 178 people in the class. Now, when they're talking about gender, they're using a very restricted version of gender. So please excuse us for this very strict definition. Statistics hasn't quite caught up with the rest of the world in terms of identifying gender. So a lot of our problems just still deal with male versus female and don't really have a neither option in a lot of the data that we evaluate. All right, so they recorded data on two variables, whether the student had pierced ears, for all of the 178 people in the class. The two-way table below displays the data. So we have the data right here. Now, suppose we choose a student from the class at random. Define event A as getting a male student and event B as getting a student with a pierced ear. All right, so find probability of B. So probability of B, remember that's probability of a pierced ear. So let's take a look at pierced ears. Now, when I'm only looking at the probability of a pierced ear, I'm ignoring the gender entirely. So I don't care about any of this part. I'm going to ignore that completely. and I'm only focused on pierced ear and the total over here. All right, that's what we call a marginal distribution and a marginal probability. All right, so I'm focused on yes for pierced ear from the total. I'm going to divide by the total number of students. That's how I'm getting the 103 out of 178. If you divide that, you get about 0.579. Now find the probability of A and B. Interpret this value in context. So probability of A and B is the probability of selecting a male and someone who has a pierced ear, so they need to be both. Now, that's still out of the total number of students, so I'm still at 178, but now I'm looking at they need to have a pierced ear and they need to be male. 19 of those 178 individuals meet both qualifications. So 19 out of 178, so about 0.107. All right, so there's about a 10.7% chance that a randomly selected student from this class is male and has a pierced ear. And finally, for part C, find the probability of A or B. So probability of A or B would be probability of male or pierced ear. Now, there are multiple ways that you can work through this. They could be male, they could have pierced ears, or they could have both. All right, so I have two separate sections that have male. As long as they're male, they would qualify. So 19, 71, that's where I'm getting these two numbers. Now there is one more group that has pierced ears. They're not male, but they only need one qualification. So yes, for pierced ears, I've already counted the 19. I did that earlier. But the 84 females with pierced ears, they would qualify also because they meet the qualification of or pierced ears. So this would be male but no pierced ears. This would be male and pierced ears. This would be pierced ears but not male. If you add all of those up, you get 174 out of 178. Now you might also notice that the number of individuals who don't qualify for male or pierced would have been 4. And if you take 178 minus 4, if you use the complement concept, then you still get 174 out of 178. All right, so two different ways that we could work through this conceptually in order to be able to get the 174 out of 178, which when we divide it is 0.978. Right, now, what is the general addition rule? Is it on the formula sheet? And if the events, what if the events are mutually exclusive? So for our definition, let's start there. If A and B are two events resulting from some random process, the general addition rule says that the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. And the reason that this works is the probability of male would have been 90 out of 178. The probability of pierced ears would have been 103 out of 178. 90 plus 103, that's 193. That's more than our total. But that's because this 90 is the sum of 19 and 71, and this 103 is the sum of 19 and 84. The males with pierced ears were counted twice if you just add up these two probabilities. So if you're adding those two probabilities together, you have to subtract the people who were counted twice in each of these probabilities so that they're only counted once. That's why we have to subtract the intersection. Now, is this on the formula sheet? Yes, it's on the formula sheet. And if events are mutually exclusive, a probability of A and B would be 0. So if this is 0, you're just left with the sum of the probability of A and the probability of B, which would be the rule that we learned yesterday. All right, so you can use the general addition rule for everything. You just need to understand that mutually exclusive events will have an intersection of 0. Now, what is an intersection and what is a union? So the definition for the event A and B, this is called an intersection of events, A and B. It consists of all outcomes that are common to both events, and it's denoted with A and then this arch right here, and then B. This is the intersection symbol. This means and. All right, so intersection goes with and, which goes with kind of like a bridge that connects the two. So this and this is kind of a connection. You could also look at this as an upside down A that was left incomplete. Now, union, the event A or B is called a union of events A and B. It consists of all outcomes that are in event A or event B, or both. And it's denoted A, and then this U shape, B. Now this U stands for union. I just tend to remember that intersection goes with and this looks like an incomplete A, and then the other one is the or. And if you remember that or is union, because it encompasses more events, then you can remember that this symbol refers to the U in union. All right, let's go to the next page. So we've taken a look at two-way tables. Now, what is a Venn diagram and what do the different components of a Venn diagram represent? So the definition of Venn diagram consists of one or more circles surrounded by a rectangle. Each circle represents an event. The region inside of the rectangle represents the sample space of the random process. So let's look at how the information in example 1 would look in a Venn diagram. All right, so the intersection of the two circles right here, this would have been male and pure steers. Now, this circle itself is for male, so the section, so inside circle A, but not including circle B, so this part where the 71 is written, that would have been male and no pierced ear. So this is a different intersection, male and no pierced ear. If you look back at our two-way table, male, no pierced ear, where those two cross is where the 77 or the 71 was. Now, outside of circle B, inside circle B, outside of circle A, so inside of this circle, but outside of the other is the 84. All right, so female and pierced ear. Now, outside of both circles would be female and no pierced ear. Since A was male, it means outside is female. And this was pierced ear, so outside would be no pierced ear. So the intersection of those two, so basically not male and no pierced ear, would be this 4. So the Venn diagram just shows you all the various intersections from the table. All right, now for our final example, example 2, according to a recent report, Pandora and Spotify are the most used music streaming apps. A group of AP Statistics students surveyed all of the seniors in their school, found that 68% use Pandora, 38% use Spotify, and 24% use both. Suppose we select a senior at random. Now, if we do this with just a Venn diagram, right? A says make a Venn diagram or a two-way table to display the sample space of this random process using events P uses Pandora and S uses Spotify. Now, sometimes you're asked for a Venn diagram, sometimes you're asked for a two-way table, sometimes you don't have a choice, and sometimes you need to connect the two. So I'm going to do both on this. All right, so I've drawn my rectangle to represent the sample space. I have my Pandora circle and my Spotify circle. Because some people use both, I have them intersecting each other. So I have this overlap here. Now, this part right here represents Pandora and Spotify. And 24% use both, and 24% as a decimal is 0.24. That's why I have 0.24 in this intersection. Now, this entire circle right here needs to be all of the people who use Pandora. So the intersection and the space outside of the intersection has to add up to 68% that use Pandora. So this section right here is actually the people who use Pandora but don't use Spotify. So they only use Pandora. So that would have been the 0.68 overall minus the portion of the Pandora people who use Spotify. So 0.68 minus 0.24 gives me 0.44. Likewise, these two need to add up to the 38% that use Spotify. So these should add up to 0.38. This section uses Pandora and Spotify. This section uses Spotify only, which means Spotify, not Pandora. So 0.38 minus the 0.24 is how I get this 0.14. And then outside, we have one more section that you need to remember to fill in. All the people use Pandora here, all the people use Spotify here, but not everyone uses Pandora or Spotify. So the proportion of people who don't use either one would be the leftovers. If you add all three of these together, you get 0.82, and 1 minus 0.82 gives you 0.18 for the complement of both events. Now, the table that I have here, there are basically two questions that were asked. So we want to know, do you use Spotify? And then do you use Pandora? You could identify this as P for Pandora, P to the C for the complement of Pandora, which would be basically a no answer. So yes, Pandora, no Pandora, uses Pandora, not Pandora. However you want to identify it, that's up to you. All right, Spotify, either they use it or they don't. So yes or no would transfer into the symbols, S and then S to the C. You should also have your totals in the margins. So the total Spotify users, if I ignore Pandora entirely, all right, so if I cover this up, ignore Pandora entirely, then I have 38% use Spotify, which means 62% do not, for a total of 100% of the people asked. If I go the other direction and I ignore this way, all right, 68% of students use Pandora, which means 32% did not, which adds up to 1 for 100% of the situation, or 100% of the students. And then 24% use both, so where these two cross each other is where my 0.24 should go. And just like before, I would take that 68 minus 0.24 to get this 0.44. And I would take 0.38 minus 0.24 to get this 0.14. And then I could either take 0.32 minus 0.14 or 0.62 minus 0.44, or I could add all these up and subtract from 1 like I did before to get this 0.18. Either way, this table gives you both the marginal probabilities for just probability of Pandora, probability of not Pandora, probability of Spotify, probability of not Spotify, and the intersections of all the different combinations I could possibly have. All right. So when you have an option, I suggest using the two-way table, not the Venn diagram. This provides more information. If you're dealing with more than 2 events, though, then you'll need to switch over to the Venn diagram. Now, finally, for letter B, find the probability that the person uses either Pandora, that uses neither Pandora nor Spotify. Now, neither nor means that they're not using either one. Right? They don't use Pandora and they don't use Spotify. So the probability of not Pandora and not Spotify, right, is that 0.18. It's the group outside, which is the group here. Right? Whichever one you chose to write down, that's how you would find that 0.18. You could take the probability of they use one or the other and then subtract from 1, which would be like the 0.44 plus 0.24 plus 0.14 gave me the 0.82. 1 minus 0.82 would give me the 0.18. If you have the two-way table here, then you don't really need to show your work for it. It's your choice how you work through that one. All right, please try these problems and we'll see you in class.